guys, um, welcome to my channel, Engineer Cinco here from CLNP. Last time guys, we discussed regarding direct current circuits or DC circuits under Physics 2. And we also discussed regarding first type of DC circuits, series and also parallel connections. Now, today, what I'm sharing to you is I will give you some example problem combination, okay? A combination of series and parallel resistor connections. So this is different guys from the two we have discussed earlier. Okay? This time is a combination of series and parallel circuits. Okay, as you can see here in the diagram. Now, I have here resistance R1. This is given 25 ohms. Okay, it is a series from the source. Okay, and there is a two resistors in parallel. After series, there is a two resistors in parallel connections. R2 is 40 ohms, and the third resistor is 50 ohms. Okay, this is the positive terminal and negative. So the current will flow counterclockwise. Okay. I'm sorry, clockwise. Clockwise. It's a clockwise. It's like this. Okay. Now, the requirement for this example is find the equivalent. First is find the equivalent resistance of this parallel connection. Okay. Second, the total resistance, okay? The total resistance of the circuits. And then, the current flowing these circuits, okay? I, or I total, or I, okay? And the voltage drop across resistor R1, okay? And then the equivalent voltage for these two resistors, okay? Now, also, we need to find the current flowing across this resistant 2 or R2. Okay. This one, guys. Okay. I2. And also, the current flowing across this resistor. I3. Okay. And power delivered to these circuits, AP, this one, power delivered to these circuits, okay, and power dissipated across resistor R1, P1, and power dissipated across resistant 2 or R2 and also for R3, okay, we need to find the power or P3, and last is the total power, okay, for these three resistors. So guys, solution, okay, is a little bit longer, so we need to solve one by one, okay. So solution, okay. Requirement is RE, the equivalent resistance of these parallel connections. As we studied earlier, the total resistance for parallel connections is equal to 1 over, okay, RE is the equivalent resistance, okay, is equal to 1 over R2, okay, plus 1 over R3, okay. This is just a reciprocal for series connection, guys, okay, as we studied earlier. As we all know, the equivalent resistance for parallel is the summation of reciprocal, okay. So, substituting the values, guys, okay, 1 over RE equal to 1 over R2. How much the resistor R2? 40 ohms, okay, plus 1 over R3. How much R3? 50 ohms, okay. So, 1 over RE or equivalent resistance is equal to, what is the common denominator guys for this one. 80. This one is 50, 100, 120, 150. 3 times 200. Okay. Common denominator is 200. Okay. So 200 divided by 40, how much guys? Let me calculate, okay? 200 divided by 40 ohms is equal to 5 times 1 is 5, okay? Plus 200 okay. Okay. 200 divided by 50 is equal to 4 times 1 is 4. Okay. So 1 over equivalent resistance is equal to 5 plus 4 is 9 over 200. Okay. So RA is equal to 200 over 9. It's just reciprocal guys, okay? So how much the equivalent resistance? How many ohms? 200, okay, divided by 9 is equal to 22.22. Okay, 22.22 ohms. Okay, ohms. So this is the equivalent resistance first requirement for this problem. Okay. Now this equivalent resistance is now connected to the R1. So they are now in series, okay? The equivalent resistance for this parallel connection is now become series with R1. So since okay, since RE equivalent resistance is in series with R1, therefore second requirement is a total resistance, okay, of these circuits. Then RT, second requirement guys, RT, then RT, okay, is equal to R1, okay, or RE plus R1. Okay guys, I hope you followed our solution, okay? So substitute the values RT, total resistance for the equivalent circuit, is equal to RE, how much? We have already calculated, 22.2, okay? 22.2 plus R1 is given 25 ohms, okay? So RT is equal to how much guys? 22.22, okay, plus 25 ohms equals 47.22 ohms, okay? So total resistance for this circuit is equal to 47.22 ohms. Okay, so we have already computed the total resistance. Now, after this total resistance, we need to find the current flowing the circuits I. This one, this I means the current. How much current flowing this circuits, knowing this connection, series and parallel. So, using Ohm's law, okay. Okay. This will be B. Okay. C. Okay. Solving for I using Ohm's law. Okay. Solving for current or I using Ohm's law. By the way, guys, this B, okay, actually this volts or B is equal to 7 volts. Okay, B is equal to 7 volts. This is the source. Okay, okay, solving for I using Ohm's law. Using Ohm's law. Okay, so total voltage, okay, is equal to I, or total current times the total resistance. Okay, since we have already given this one, guys, which is equal to 7 volts. So substituting the value 7 volts is equal to, this is a source, okay, battery. 7 volts is equal to I, is the unknown, times how much the total resistance as we computed here, equal to 47.22. Okay, so I is equal to, let me calculate, guys, 7 volts divided by 47.22 ohms is equal to 0.14. Okay, 0.148 ampere. Okay, which is also equal to I1 because they are in series. Okay, this is also equal to I1. As you can see here, guys, this is the total current flowing. Okay, so once it is passing the series resistor, the current flowing across this resistor is equal to I. So I1 is also equal to I. Okay, and this is also equal to the equivalent resistance. Current flowing against these two resistors is also equal. Okay, so equal to I. Okay, IA, or equivalent current for these two. So we have already calculated this one. Okay, now the next requirement will be solving for the voltage drop across resistor 1. Okay, so letter D, since we have already the current flowing, we can find the voltage drop across resistor R1. So solving for voltage drop or B1, okay, solving for B1, solving for voltage drop across R1. Okay, it's equal to, using Ohm's law. Okay, so B1, this is B1. Okay, B1, okay, since it is R1, so B1, voltage across R1. B1 is equal to I1, okay, times R1. Okay, so we have already I1. This one, guys, I is equal to I1. Okay, also equal to equivalent current. So equals I1 is 0.148 ampere times how much the R1 resistance? R1 is 25 ohms. Okay, 25. Okay, so equal to B1 will be, okay guys, let me calculate. 0.148 ampere times the resistance is 25 is equal to 3.7 volts. Okay, equal to 3.7 volts. So this is the voltage drop across resistance 1 or R1, B1. Okay, next requirement will be, okay, let me write here. Okay. We have already calculated B1. Now we need to solve the equivalent BE, equivalent resistance for these two parallel resistors. Okay, BE. So solving for BE. Okay. Solving for BE. Okay. This one, guys, voltage drop across equivalent resistance. Okay. BE is equal to IE times the equivalent resistance, which is RE. Okay. RE, we have already calculated here, right? This one, guys, RE. And the IE is also equal to I1. Okay. So this one and this one, guys, RE. Okay. So substituting the values, IE is equal to 0.148 ampere. Okay. Times the equivalent resistance, you have already calculated. RE is 22.22. Okay. 2.22 ohms. So BE, the voltage drop across these two resistance, is equal to BE. So let me calculate, guys. 0.148 ampere times equivalent resistance is equal to 22.22 ohms. So there are 3.28 volts. Okay. Okay. So we have already solved for this BA. Now next requirement is EF. How much the current flowing across resistor 2? So I2. Okay. By the way, guys, this voltage drop across equivalent resistance is also equal to B2 and B3. Okay. It's also equal to B2 across resistor 2 and also equal to B3 voltage drop across resistor 3. Okay. So this is the value. Now F, solving for the I2 current flowing across resistor 2. Okay. Solving for I2. This one, guys, I2. Okay. Current flowing across R2. Okay. So just simply, guys, using Ohm's law. Okay. So B2 is equal to I2 times R2. Okay. B2 is also equal to BE, which is 3.28. Okay. Equate this current to the volts 3.28 is equal to I2, which is the required. How much the resistance to R2 given, guys? It's equal to 40 ohms. Okay. So I2 is equal to, okay, let me calculate guys. Okay, 3.28 volts divided by 40 ohms. So equal to I2 is 0.082 ampere. Okay, so this is the current flowing across resistor 2. Next is the I3. Okay, okay, solving for I3. This one guys, current flowing across resistor 3, I3. Okay. So again, using Ohm's law, B3 is equal to I3 times the resistor 3. Take note guys, the voltage drop across resistor R3 is equal to B2, also equal to equivalent voltage BE. So how much? 3.28, okay, is equal to I3. How much the resistor 3? R3? 50 ohms. Okay. So I3 is equal to, okay, let me calculate guys. 3.28 okay, 3.28 volts divided by 50. So there will be 0.0656 ampere. Okay. So to continue further, the next requirement will be solving for the power P. Okay, power delivered to the circuit. Okay, so P will be equal to solving for power delivered to the circuit. Circuit. Okay, so P is equal to BI. Okay, means voltage times the current. Okay, so this volt is BT. Okay, the total source is given 7 volts. So power equal to how much? B is 7 volts. Okay, 7 volts times the current. Okay, I. How much I? I is equal to 0.148. 0.148 ampere. Okay, so power is equal to how much guys? 7 volts times current is 0.148 ampere. So there are 1.036, okay, W. This W guys is a unit of power. This is in terms of watts. Okay, so this is watts, huh? Okay, now other requirement, we need to solve for the power dissipated across resistor R1 and so on for R2 and R3. So again guys, let me write somewhere here. Okay. Okay. I. Power solving for power. This time this is regarding for the resistance R1, R2 and R3. Okay, solving for power for each resistor, okay? For each resistor. Okay? Okay. P1 is equal to, what is the formula for power, guys? I squared, okay, times R, 1. Okay, substituting I or I1, how much? 0.148, okay, 0.148 ampere, okay, squared, times R1 is 25 ohms. Okay, so P1, how much, guys? Okay, 0.148, this is squared, huh? Squared, guys, times the resistance, this is 25 ohms, equal to 0.54. Okay, 0.547 watts. Okay, so this is the power dissipated for resistance 1 or resistor 1. Okay, and P2, we can write here, equal to, P2 is equal to I2 squared, okay, times R2. So equal to, how much the I2? I2 is 0.082 squared times R2, 40 ohms. Okay, so P2 is equal to 0.082 squared times 40 ohms is equal to 0.268 watts. Okay. The next is the P3. Okay, so P3 is equal to I3 squared times R3. Okay. How much I3? I3 here is computed 0.06 0.065 okay, squared times R3. How much R3, guys? 50 ohms. Okay. So P3 is equal to 0.0656 squared times 50 ohms. So to 0.215 watts. Okay. Okay, guys. So the last requirement will be, it's I. Last requirement is the total power dissipated for the 3 resistors. Okay. Solving for PT. Okay. PT, guys, is the total power dissipated for 3 resistors. Okay, R1, R2, and R3. So it is equal to, total power is equal to P1 plus P2, okay, plus P3. So substituting, how much P1? 0.547 watts plus P2 0.268 watts plus P3 is 0.215 watts. So total power, summation of these 3 powers, okay, 0.547 plus 0.268, okay, plus 0.215 is equal to 1.03, okay, is equal to 1.03 watts. So that's it, guys. I hope you understand our sample problem related to the combination of a series and parallel connections of resistors, okay, under the DC circuits. So we have already calculated the last requirement, total power. So again, guys, I hope it will be helpful those students who are studying DC circuits under P6 too. And I'm hoping also some problem that I'm sharing will be easy to you guys. Okay. So again, thank you for watching and have a nice day.